Welcome to a new teardown video. This time it's a pen plotter XY plotter writer autograph Moseley Autograf model 2D 2AM XY recorder. They got many names, those cool recorders. And this was really how you did data recording back in the good old days. And this one was on my wish list for a long time. And finally, one of my loot collectors was so friendly to get me one. Hewlett-Packard. So this can't be bad. I am a little bit curious about the user interface, how I do this and that. This one must be the power on off button, and I actually connected this, so let's do the first power on, blow up together, right? So if this is an off, I think we should be fairly safe. Let's turn on the good. So that is mains is applied and we are ready. Okay. You like that sound? Ooh. It's moving. But what made it move? Because it's in standby, right? Ooh, this switch, isn't this switch supposed to be... Okay, pen down is working. So this standby switch here, that can't be good. This can't be normal. There's it should be a hold in both, I guess. So this is in volts. It is reacting on this. The zero, it's not reacting on the zero. I guess I'll be able to move it on the zeros, right? Nah. Okay. So we got some. The paper is in hold. So now the paper should be... Let's see. Yeah, there's sticky. And if I put it in off, yeah, so that works. There is a static field in here with some electrical lines just under the white surface. It can set some high voltage on it or something like that, right? So it will make the paper stick. Hold. Yeah. Wow. That really holds the paper. That is crazy how well that worked. All right. Let me try and input some DC and something and see if this works. Before we look inside, we better look on the rear side. So, remote pen. Also got digital connector. That one I'm a little bit worried about. What is that? So there's a retransmitting slide wire, something. And of course the fuse and voltage, super good. Okay. I finally got this working. By massaging the different knobs here, I actually got it to working. And I also figured out about the inputs and stuff. So, look at that. If I turn the zero here, so I can move it. It is now connected to 2 DC supplies. I am running in 1 volt steps. So if I change the voltage on one supply and then I go to the other one and change the voltage here. Ooh, there's a lot of overshoot but basically it is working. There's a lot of regulation on motor controlling, and also the record here. See, it'll take down the pen. If I connect this spring, this one will fall down by the spring. It's supposed to lift this up, right? And then this will let the pen go down on the paper and just be pressed down on the paper by this little spring. So that is something I need to play with a little bit. Now I figure it out. By playing with the variable, because now it's in 0.5 volts per division and I want 1 volt per division, just to be a little bit difficult. So what I'm doing is I'm putting in 4 volt and pretending this is my line at 4. So if I change from 4 to 5 volt, 6, 7, see, it goes a little bit too much. Okay, so I dial down the variable a little bit down, and then I adjust the voltage for 4, and then dial the 0 to 4, and then I try again. After doing this a few times, you'll be able to reach the exact scale of 1 centimeter per volt, if this is what you aimed for, right? And of course you can do the same on the other axis. Then it is calibrated and ready to use for the measurements you wanted to use it for. And as far as I see, you can also do time on X. So if you're going to time, is it also time over here or what? I'm a little bit, so if I put it into time, so standby, and then reset, ooh, then it goes crazy. That is not good. It has to be something with the 0, okay? So I need to play with that. Okay, it was just user error. So the 0 here is very important when you go into time. Otherwise it's gonna hammer all the way to the left. So now it is in reset mode. And we can start the sweep. And it will of course do a time sweep all by itself by the speed. And now it is seconds per centimeter. So a half a second per centimeter. So now you can perform a really, oh wow, cool. And then it's just gonna go to the end and nothing else. And then you just go all the way back to standby. I love it. But I think there's something wrong with this switch, because this can't be right. I think we need to see what is inside, right? Let's tear down. And now we are inside. And up here we got the 2 motors. So this is X moving up. If I let it go, ooh, it's gonna fall down. And this is Y. It's connected by 2 bands and a roller here in the middle. So the cool thing about transferring your position via a rotating joint like that and moving this, the 2 parts in exactly that joint, that means it will keep the position, right? No matter where we go like this, see? It's just gonna stay. And then you can move like this. That is really, really cool. So you keep the weight down and you can still move the position. That is absolutely cool. And also, that gotta be the power supply and two similar circuit like this. I think this is input amplification and stuff. But what have we got right here? Nuvistors. They just keep showing up and all sorts of stuff. Wow. Tiny little tubes. And if you want to know more, please search in my videos and you will find actually a few videos about nuvistors. And this is the power supply that is doing the paper hold. So that is mounted up here in a tiny little package like this. I don't know. And it is wired for 117 volts only. Pretty cool. So that means this goes to a winding on the transformator. Got some capacitors here, some more power supply part, and a, what is that? Is that a relay or something? I wonder what kind of motors this is, because we got some like 4 wires coming out of them, and there's a label and stuff. Now I am a lot more in. I found out the entire front panel, you can just pull it out. It is only held by magnets onto that plate on each side, so you can pull this out. Also, I found out it's really difficult to see. So those are connected to the motors, and I guess they go around some wheels, and I think those goes to some of those potmeters that we see up here somewhere. I don't know exactly where they are, but I'm going to find out how the position's working. And so all the wires from the motors, they come here and then they go all the way up here in this connector. And those 4 screws for the entire power supply, and I guess this is the amplifier, and maybe this is also the motor drivers, because look at that. This looks a lot like motor drivers. And ooh, some germanium transistors. And we see 2 modules with the same numbers on them. So maybe this is motor control loop something. And there's a black unit here with another connector in the end. I don't know what that is either, but there's a number or name here. So I think we should consult the manual to figure out what that is. And also I found a module down here. And this is, we got a lot of wires and stuff coming out of this. So this has something to do with all this stuff and some shielded cables. So this could also be position amplifying, something sensing about that. So yeah, there's a little bit more to see, and it's a little bit funny. Here there's a connector, so you can release this cable that goes to all the front stuff, but in the other, you just unscrew here, and then so you can take the entire front panel away for service. I took it a lot more apart, and now we can see a lot better how everything works, how it's transferring the position here of Y. And see, there's a spring inside this one, and also in that one. So this hold those 2 bands nicely tight, so that works. And it goes up here and it's connected to this wheel, and then it can move.
But if you look really careful under here, I don't know if I can get this as focus. Here is a long linear potentiometer. And this is how it knows the position. So this is the feedback loop. And also, there's one for the other. And this goes all the way up here. So this is the relay or the solenoid that lifts the pen, the yellow and the green. It goes up here in this little connector, and of course there is a coax cable, a shielded cable for the pot meter of the position, and it goes all the way up here where this unit is. But it also goes to the front panel, to the zeroing, and so I think this is that signal goes in series with the zero pot meters, and then back to this amplifier, and then back in cables again to the motor driver. So that is at least what I figured out so far. Oh, don't you just love this funny little cable? And here's the switch that I was talking about that just doesn't feel right. See, it can't lock in the down position, but it can lock in the up. So there's a mechanical problem because the switch looks I don't know, it's difficult to show here. Can we get some more light maybe? But the switch looks really identical, but why isn't it locking? Yeah, so that is difficult to replace because there's a lot of sections. And also what I saw is this shielded wire here that was almost touching this wire, so I tried to separate them a little bit, and I cleaned all the mechanics and the bearings, everything that moves, and it is a lot more smooth now. So when seen from the top, I really like this method of transferring. This position, isn't that just cute? So this is the Y motor and this is the X motor, and that goes through this tiny little steel wire through all those wheels, so it grabs in each end and pull this perfectly nice and straight. And now it's moving really nice and smooth. Here on this side we got a normal bearing, or some two bearings down there, and here is a linear bearing, I guess. And this one was a little bit dirty, so I cleaned it. And here is the pot meter for the X, and I tried to clean that as well. And they used a lot of nice sliders, so they really did all they could to do it really nice and good. And look at the gearing here, and everything is just top quality as always. Oh yeah, when you pull out the entire front panel, you'll get access to some trimmers. And the first three, that is like normal accessible trimmers for normal calibrations. But if you're more certified and you read the instruction manual, then you can unscrew this and get access to the secret trimmers, where all the important stuff that is only for guys with the instruction manual. And I don't have the instruction manual. I can't find the schematics. I can't find anything online. So I need to go back and Google some more. It's really difficult. But I think I'm gonna try and clean this up a little bit more and then assemble it again. So to get this plotter printing, let's look a little bit on the pens themselves. So this is the holder that is mounted in the plotter, right? So the pens, I guess they are cheap, throw away when dead. But of course you can't buy anything like this anywhere. But the measurements for this is quite simple, and also the locking mechanism, how it works, is really simple. So I'm going to, I actually already did, 3D designed exactly this, just for normal ball pens, to stick it in up here, and then it will lock here, and we can see how the first one is going to be. I think soon it's going to be ready, and yeah, it's looking a little bit like this already. So that was actually one big success. So I just measured all the parameters from this one. Okay, it goes in from this, and even the distance from this edge to the locking edge, that is very, very critical. They try to make it a little bit flexible by making it like really thin, so it does actually stick in, and then kind of there's a grippy locking feeling. So what I did is I took the measurements and went through Fusion, and I thought I just did it more or less. Okay, my ball pen is actually a little bit too long. I could just put it down like this, right, about a half a millimeter or something. But I don't know if that is that critical. It has something to do with the pen lift. So if we stick this in here and then turn it, should be able to, maybe that way. Yeah, and then it locks. So let's see if we can make some curves. So this is my first try with the ball pen. Well, it is making curves. That is actually quite funny. Making a drawing of a 0.1 Hertz sine wave, or actually two of them, where one of them is a little bit slower than the other one. So this would have been really difficult to recreate on a scope. So this is actually a scope picture, you could say, right? Huh. Quite funny. I don't know why I find this funny. But it's pretty cool that it is actually working. I needed a little bit more weight on the tip. I just put a washer there, and it kind of works with the ball pen. I got a little bit of mechanical hysteresis or something in the stuff that moves. It's not super smooth anymore. Well, I tried to clean a little bit, but maybe it needs a little bit more cleaning and a little bit more love and care. But hey, it's over 50 years old, this thing, and it still works. Thank you very much for watching.